Hello student, welcome and very good morning to you. Today I will be discussing the solution of IRODOV question number 13, 14, 15 and 16. This solution will be extremely helpful for the preparation of JEE Main and Advanced. I have already uploaded the IRODOV solution of question number 1 to 12. This solution also be helpful for the JEE Main and JEE Advanced. I hope these solutions will be extremely helpful for you. Please like and share the video and please write a comment on it because this comment will be extremely helpful to make the next video for you. Question number 13. Point A moves uniformly with velocity v so that the vector v is continually aimed at the point B, which in turn moves rectilinearly and uniformly with velocity u less than v. At the initial moment of time v is perpendicular to u and the point is separated by a distance L. How soon will the point converge? Okay, look at this. This is the point A. B is at a distance L from the A. Okay, this is the A and this is the B. Distance between A and B, this is the L initially. Now A moves along this direction. Okay, and B moves along this direction. No problem. After the time A is at A dash and B is at B dash. Okay, no problem. So look at this. The direction of A when is at A dash is directed towards B dash and this is directed along this direction. Okay. Suppose this angle alpha. So look at this. This angle, this angle also alpha. Here direction of velocity along this direction is v, and here direction of velocity this is the u. Okay. So component of velocity of v along this direction this is the v cos alpha. Okay. Suppose t naught be the time to converge the point A and B. Okay. Look at this. The component of velocity of u along this direction this is the u cos alpha. So look at this here b dash this equal to velocity of b into this is the t naught. Okay. So this distance is equal to distance traveled by a in the same time. So look at this. This is the v naught cos alpha into dt. Integration is 0 to t naught. Therefore, from look at this integration 0 to t naught cos alpha dt. This equal to this is the u t naught by v. This is equation number 1. Here initial distance between A and B is L. Okay. So L equal to this is the integration of this is the relative velocity V relative velocity between A and B, that is V minus this is the u cos alpha into time. Time means dt and limit of integration from 0 to t naught. Okay. So look at this here v naught v into dt, this is the 0 to t naught minus this is the u, this is the cos alpha into dt, this is the 0 to t naught. Okay. So look at this here, this is the v into t naught minus this is the u, and look at this here integration of cos alpha dt this equal to, this is the u t naught by v. So look at this is the u t naught by v. Therefore, look at this is the v square minus u square into t naught divided by v, this equal to L. Therefore, T naught equal to, this is the L V divided by, this is the V square minus U square. Okay, understood? Now question number 40. Okay, look at this. A train of length 350 meters start moving rectilinearly with constant acceleration. This is the 3 into 10 to the power minus 2 meter per second square. T equal to 30 seconds after the start, locomotive headlight is switched on. This is the event 1. And tau equal to 60 seconds after the event, the tail signal light is switched on. Find the distance between this event in the reference frame fixed to the train and to the earth. How and what constant velocity v relative to the earth must certain reference frame k move for the two events to occur in the same point. Look at this. Suppose this is the line of motion of the train. This is the A and B with the initial position of the train. Look at this. This is the A and this is the B. After 30 seconds, look at this. Then position of A be A1 and position of B be B1. Okay. And after 60 seconds later, the position of, look at this is the A1 be A2 and B1 be, look at this is the B2. So obviously here A1, obviously here AB equal to A1 B1 equal to A2 B2, this equal to, this is the 350 meter. No problem. Okay. Now, why after 30 seconds, look at this, A reach A1. So velocity at A1, this is the 0 plus A into, this is the 30 second. So this is the 30. Now acceleration is equal to, look at this, 3 into 10 to the power minus 2. So look at this is the 3 into 10 to the power minus 2 into 30. So look at this is the 0.9 meter per second be the velocity. Look at this, at this instant event 1 occurs. Okay, so after 30 seconds, the A1 moves A2. Now we have to calculate A1 A2. So look at this here, A1 A2, this equal to, this is the V1 into 60. Okay, V1 into 60 plus, this is the half into A, this is the 3 into 10 to the power minus 2, and this is the 60 square. No problem. So look at this, V1 is the 0.9 into 60 plus, look at this is the half into A. So look at this, half into, this is the 3 into 10 to the power minus 2, and this is the 3600. No problem. So look at this, 10 to the power minus 2 and 2 0 are cancelled out. So look at this here, this is the 54. Okay, plus this is the 18, this also 54. Therefore, this is the 108 meter. At this instant, the event 2 occur at the point B. Now you know A2 B2 is equal to 350 meter. We have to calculate the B2 A1. Okay. So look at this here, A2 B2, this is the 350 meter and this is the 108 meter A1 A2. Therefore, look at this A1 B2, this equal to 350 minus this is a 108. So this is the 242 meter. Therefore, distance between two events, this is the 240 meter. Now, how and what constant velocity v relative to the earth must a certain reference frame K moves for the two event occurs at the same point. Now, where reference frame moves from A1 to B2 in the same time interval, that is the 60 second, the reference frames observe that two events occur simultaneously. Therefore, velocity of the reference frame, this is the distance travel, this is the 240 meter divided by time 60 second. So look at this, this is the 242 divided by 60. So look at this is the roughly 4 meter per second. Okay, understood? Now look at this question number 15. An elevator car whose floor to ceiling distance is equal to 2.7 meter start ascending with constant acceleration. This is the 1.2 meter per second square. 2 seconds after the start, a bolt begins falling from the ceiling of the car. Find number one, the bolt free fall time. Now the concept required to solve this numerical, this is the relative acceleration A12. This is the A1 vector minus A2 vector. Okay. The time of fall T equal to, this is the root over 2h by, this is the relative acceleration. Okay. Look at this, the maximum height under the gravity, this is the u square by 2g. Okay. Now look at this. Here, the acceleration due to gravity is directed vertically downward, and the axis of the lift this is the upward. So relative acceleration, this is the A12, this is the 9.8 plus this is the 1.2. So this is the 11 meter per second square. Now the free fall time of the bolt. Look at this here. The displacement of the bolt, this is the 2.7 meter. Relative acceleration, this is the 11 meter per second square. So time to fall the bolt, this is the root over 2h by g. 2h by a. A means this is the 11 meter per second square. So this is the 11. Therefore, this is the 2 into, look at this, 2 into, this is the 2.7 divided by 11. Therefore, look at this is the 5.4 divided by 11 root under. So this is almost zero point 0.5. Okay. Now almost zero point 0.5. So this is the almost 0.7 second. Okay. The displacement and the distance covered by the bolt during the free fall reference frame fixed to the elevator shaft. Now displacement. Now displacement of the bolt, this is the, suppose this is the YB, this equal to, this is the UT plus half GT square. Okay, no problem. Here initial velocity U, this is the acceleration into time, that is U equal to, this is the 1.2 into 2, this is the 2.4 is the directed upward. Therefore, displacement YB, this equal to, this is the minus 2.4 into T. T means this is the 0.7 second, 0.7 second plus half G. G is the 9.8 into, this is the 0.7 whole square. So look at this, if you take common 0.7, this is the minus 2.4 plus, look at this is the 9, this is the 4.9 into 0.7. Okay. So look at this is the 0.7 into, this is the minus 2.4 into, look at this is the 4.9 into, this is the zero point 0.7. Okay. So look at this is the 0.7 into minus 2.4, and this equal to almost 3.4. Okay. So look at this, the displacement is the 0.7 meter. Now distance travel, look at this, the trajectory of the bolt initially rise in the upward direction, then fall by the distance of, this is the 0.7 meter. So look at this, in this direction velocity is the, this is the 2.4 meter per second in the upward direction. So look at this, the distance traveled d equal to, this is the 0.7 plus, this is the 2 into, this is the v square by, this is the 2 into g. G means this is the 9.8. Okay. 2 and 2 cancel out. Okay, no problem. Therefore, this is the 0.7 plus, look at this, this is the 2.4 whole square divided by, this is the 9.8. Look at this 2.4 whole square. So this is the 5.76. This divided by 9.8. This almost is zero point 0.6. Therefore, this is the zero point 0.7 plus zero point 0.6. That is, this is the 1.3 meter is the distance traveled by the ball. Okay. Look at this. Question number 16. Two particles A and B move constant velocities v1 and v2 along the two mutually perpendicular straight line towards the intersection point O. Okay, look at this. Suppose this is the two straight line, this and straight line this. Okay. So here one particle moves along this direction and other particle moves along this direction. Suppose this is the particle A and this is the particle B. Okay. The particles are located at L1 and L2 distance. Look at this. If this is the O, so OA equal to L1 and OB this equal to L. Okay, no problem. How soon will the distance between the particle becomes the smallest? Look at this. When after the time t, when A reaches the point A1 and B reaches the point B1, then their distance becomes minimum. This distance becomes A1 B1. So look at this. If V1 be the velocity of first, so look at this here. V1 be the velocity of first. So look at this. This is the A1. This equal to V1. This is the BB1. This equal to, this is the V2 into T. Therefore, OA1, look at this, OA1 is equal to L1 minus V1T. And OB1, this is the L2 minus V2 into T. So look at this here, A1 B1 square, this equal to, this is the L1 minus V1T whole square plus, look at this, L2 plus L2 minus V2 into T whole square. Okay. Suppose A1 B1 this equal to X. Therefore, X is equal to, look at this is the L1 minus V1T whole square. Okay. Plus, this is the L2 minus, this is the V2T whole square. As A1 V1 is minimum, so d dt of, this is the X square equal to 0. Therefore, look at this is the 2 into L1 minus V1T into ddt of this. So this is the minus V1. Okay. Plus, look at this is the ddt of, look at this is the 2 into L2 minus V2 into T into, this is the minus V2. This equal to 0. Therefore, look at this is the, this is the L1 minus V1 into T into V1. This equal to, this is the, this is the minus, this is the, this is the minus L2 into, this is the V2T into V2. Okay. Therefore, look at this here, L1 V1 minus V1 square T. This equals to, this is the minus L2 V2 plus, this is the V2 square T. Therefore, L1 V1, look at this, L1 V1 plus, this is the L2 V2. This equal to, this is the V1 square plus V2 square into T. Therefore, T equal to, this is the L1 V1 plus L2 V2. Divide by this is the v1 square plus v2 square be the time to reach the minimum distance. To find the minimum distance, we have to put the value of t in this equation. Then x is obtained. X is the minimum distance between A and B. Okay. Many thanks for watching this video. This video will be extremely helpful for JEE Main and JEE Advanced. Okay. Thank you.